Hi students, I will go through all 5 exercises for the elementary algebra TSI practice in this video. Okay, we'll start with problem 1 in exercise 1. We need to simplify this expression and find what it's equivalent to. So the first thing you want to do is get rid of parentheses. If you look in front of the first parentheses, there's just a 1, so we don't really need these parentheses. Okay? Now in front of the second parentheses, there is a -1. So that means we definitely are going to need to distribute that into the parentheses. And what we end up getting is, remember, we're going to take off the first parentheses. 3m minus 8p squared plus 5m squared minus 3p. Now in the second set of parentheses, we're going to distribute that -1. -1 times 4p is -4p. -1 times 7p squared is -7p squared. And -1 times -8m is +8m. Okay, so now that we've distributed, we have gotten rid of our parentheses. Now we're going to look for like terms. Now we have a lot of different variables here. So if I look at my answer choices, they all start with 5m squared. So I'm going to start with my m squared term, and the 5m squared is the only one that is the m squared. So we're going to put that one first. So 5m squared. Okay. Next I see they have the m next, so I'm going to locate all of my terms that have just m. I have 3m and I have 8m. So if I combine those, I'm going to get +11m. If I look at my answer choices, I've kind of narrowed it down to this last one. That's the only one with 11m. But let's just keep going to make sure that we did it correctly. But we're thinking it's probably D. So now I'm going to look for my next term, which is going to be my p squared term. I've got a -8p squared and a -7p squared. Those are going to combine to make -15p squared. And yes, D still looks good. B and A both have that as well, but D is still looking good. Our last term are our P's. I've got -3p, -4p. Those are both going to combine to make -7p. And yes, it's still got to be the last one. So the answer to exercise 1 is D. All right, number 2. Again, we are simplifying here. Remember, when you are subtracting or adding fractions, you need to find a common denominator. Our denominators are x and y. They're not the same. If you can't find a common denominator, and it's especially difficult with fractions, you would just multiply them together. So x times y is going to be xy. Okay? So I want to make both denominators look like xy. If I look at the first fraction, I had to multiply that denominator by y to make xy. So I also need to multiply my numerator by y. Since I already have one y in my numerator, if I multiply by another y, it's going to make y squared. Y times y is y squared. Now if I look at the other fraction, I had to multiply the denominator by x to get xy. So that means I need to also multiply the numerator by x. I already have an x in the numerator. If I multiply that x by x, it's going to become x squared. So what we have now is we have common denominators. Now we can put them together. Our new denominator is xy. For our numerator, we just need to combine these. I have a 2y squared minus a 3x squared. Well, those are not like terms because they have different variables, so I cannot put them together, so I'm just going to rewrite 2y squared minus 3x squared, and that's as simplified as it can be. And so your answer is A. Number 3, to simplify this expression, we're multiplying binomials. So the way that we do that is we use FOIL or double distribution, or you can use the X method. I'm just going to use double distribution, which is kind of the same as FOIL. We're going to start with our first term, multiply it by the first term in the other parentheses, take that same term and multiply it by the second term in the other parentheses. Then we'll go to the other term in the first parentheses, the negative y, multiply that by the first term in the other parentheses, and multiply it by the other term in the other parentheses. So let's see how this works. X times x is x squared. X times 2 is 2x. Then we go to the negative y. Negative y times x is negative xy, or negative yx. And negative y times 2 is negative 2y. So then you look at these terms. None of them are alike. They would have to have the same variable or variables. They're all a little bit different. So this is our solution. And the answer that looks like that is C. So the answer to number 3 is C. Number 4. It wants to know the value of this expression when y equals 1. So what that means is whenever you're given a value for a variable, if you have another expression, you can replace that variable with that value. So that's really what we want to do here. And that would be fine, but we can work a little smarter. If I look at my numerator, I can see that all 3 of these terms are like terms. 2y plus 1y plus 7y. So if I combine those in the beginning, it's going to make less work for me. 2y plus 1y is 3y plus 7y is 10y over y minus 2. Now let me replace the y's with 1. So what it's going to look like when I replace it, it's going to be 10 times 1 over 1 minus 2. And then I just have to simplify that. 10 times 1 is 10. 1 minus 2 is negative 1. And 10 divided by negative 1 is negative 10. So the answer to number 4 is A. For number 5, it's very similar to number 4. It gives us a value for a variable. So we want to replace everywhere we see g with negative 3. This is called evaluating, when you replace a variable with its value. So let's go ahead and try that out. The g is negative 3. So in the first g squared, I am squaring the entire g, which is negative 3. You've got to put that negative 3 in parentheses. Minus 4 over, in my denominator, negative 3 plus 4. Okay, so now we just have to simplify. Negative 3 squared means negative 3 times negative 3, which is positive 9. Okay, now let's simplify our numerator and denominator. Our numerator, 9 minus 4 is 5. Our denominator, negative 3 plus 4 is 1. And 5 divided by 1 is just 5. So the answer to number 5 is B. There's exercise 1 complete. All right, this exercise is all about solving equations. So the first thing you always want to do if you have parentheses is to distribute. So for number 1 here, the first thing we're going to do is distribute the 5. Okay, we always want to put a line down the middle if that helps. All right, let's do this. 5 times 2x is 10x. 5 times negative 5 is negative 25. Bring down your equal sign and your 10. Now we want to move our, we want to make sure all of our variables are on one side. We have all our x's on the left. So then we want to move all of our constants to the other side. Those are just the numbers. So that negative 25 we want to move over. We're going to do that by adding 25 to both sides, the opposite of minus. So now we have 10x equals 10 plus 25 is 35. And then the last thing we would do is get rid of the coefficient in front of our variable by dividing both sides by that number. 10 divided by 10 makes 1, or 1x, which is just x, and 35 divided by 10 is 3.5. So there is your answer to number 1. Now, if you ever wanted to check, maybe you're having trouble solving, what you could do is you could go back to your original equation and replace the variable with the answer to see if it's true. It would look like this. 5 times 2 times 3.5, I'm replacing x, minus 5 equals 10. Okay, and then you would simplify. 2 times, and that's 3.5, is 7, and 7 minus 5 is 2, and 2 times 5 is 10, and 10 equals 10. So you can see that it works. So you can always plug in the answers to check it that way. All right, number 2, let's solve. We have parentheses. What's outside the parentheses is -1, so we're going to start by distributing that in. -1 times -5x is positive 5x. -1 times 36 is minus 36, or negative 36, divided by 2 equals 2. Now, if you ever have a denominator, you can get rid of it by multiplying both sides by the denominator. So my denominator is 2, so I'm going to multiply the left side by 2, and I'm going to multiply the right side by 2. On the left side, these 2's cancel. So on the left side, I just have 5x minus 36. On the right side, I have 2 times 2, which is 4. Now, we want to get all our variables on one side, which we have, all the 5x's on the left. So we want to move our constants to the other side, to the right. We're going to move the negative or minus 36 by adding it to both sides. So now on the left we have 5x. On the right we have 4 plus 36, which is 40. And then the last thing we'd want to do is divide by our coefficient in front of our variable, which is 5. So x equals 40 divided by 5 is 8. So your answer to number 2 is D. Okay, number 3 is a proportion. Whenever you have two fractions that equal each other, you are going to solve by cross multiplying. So we've done this a lot this year. And what you're going to get are cross products. -2 times x is -2x. 3 times 12 is 36. These are your cross products, and they're always equal. So now I've made a little tiny equation. We're going to solve this equation by just getting rid of the coefficient in front of x, and we'll do that by dividing both sides by that -2. So x equals 36 divided by -2 is -18. So your answer to number 3 is -18, B. Number 4 is an inequality, which just means this symbol right here is not an equal sign. It's a greater than equal, less than or equal. You're going to solve it just like an equation. There's only one extra rule. If you need to multiply both sides or divide both sides by a negative, this symbol here, you would have to flip its direction. Okay? So let's go ahead and solve this one. We want to get the variable always on the left when you're solving an inequality. We already have our 2x on the left, so we're going to move that 3 to the right by subtracting it from both sides. So we've got 2x on the left. Bring down your greater than. 9 minus 3 is 6. Now we're going to get rid of our coefficient in front of x, the 2, by dividing both sides by 2. And x equals greater than, x is greater than 6 divided by 2, which is 3. So your answer to number 4 is C. No, it's not. My mistake. Okay. I read the question wrong. This is the inequality solved. It says, which of the following can be the value of x? X has to be greater than 3. So x cannot equal 3. So I was mistaken there. My bad. The only number on here that's bigger than 3 is 4. So the answer is D. Sorry about that. That's why I hesitated a bit for a sec. Hope that makes sense. Okay, here's another inequality. This one, if you look at the answers, they actually show the solution, whereas number 4 wanted a possible value of x. So make sure you read really carefully because I messed up on that last one. Okay. So first of all, we want to get all our variables on one side. That x on the right, we need to move to the left by subtracting it from both sides. Okay, so this minus x is like minus 1x. So on the left, we have -3x minus 1x, which is -4x, plus 6 is greater than -10. Okay, so all our x's are on the left. Now we're going to move our constants to the right. That positive 6 we're going to move over by subtracting it from both sides. So we're going to have -4x on the left is greater than -10 minus 6 is -16. Okay, the last step, the coefficient in front of x is -4. We're going to divide both sides by -4. Remember, I said if you divide both sides or multiply both sides by a negative, which we are, you have to flip the symbol here. So that means On the left, we have x, but our greater than becomes a less than. On the right, negative 16 divided by negative 4 is positive 4. So the solution here is x is less than 4, which is C. Okay, this section is about systems, which is two or more equations. Now, I know a lot of you only learned how to do it on the calculator, so doing it by hand for some of you may be challenging. I'm going to show you how I would do these by hand, but then I'm going to show you kind of like a little trick you can do if you don't know how to solve a system. So the method that a lot of students like is the elimination method, and that's where you line the equations on top of each other, and then you add them together, and you get like another little equation. They have to be in the same form, though. So if you look at my equations right now, I've got x first on the left, but I have x second on the right. So if I was to switch these two terms to make negative x first, positive y equals 2, then I would have my x term first, my y term second, and my my coefficient on the other side of the equal sign. Okay, so let me rewrite that so you can see what it looks like. So we've got x plus y equals 4 and negative x plus y equals 2. So the way the elimination method works, if I was to add these two equations together, I would want either my x's or my y's to cancel out, either that or that, okay? The only way that's going to happen is if the numbers in front are opposites. Now, if I look at my x's, I've got a 1 in front of this one and a negative 1 in front of this one. Positive 1 and negative 1 are opposites, so these two equations are ready to add. So let's go ahead and add them. These two go away. They make 0x, or 0. Then I've got y plus y, which is 1y plus 1y, which is 2y, equals, and 4 plus 2 is 6. Now I have a tiny little equation, and I can solve for y very easily by dividing both sides by the coefficient of y, which is 2. And that's going to give me y equals 3. Okay, now if I look back at the problem, it says, if we have this system, then x equals what? Well, I need to find x, but I have only found y. The way to find x is to go back into one of these top equations up here and plug in y with 3 and then solve for x. So I think I'm going to use that first equation. I'm going to rewrite it. X plus y equals 4, and I'm going to replace the 3, or I'm going to replace the y with a 3. So it's going to be x plus 3 equals 4. So to solve for x, it'd be very easy. I'd move the 3 to the right by subtracting it on both sides. And then x equals 4 minus 3 is 1. So the answer to this one would be 1, or B. Okay, so that was one method to solve a system by hand. Now, if you're not familiar with that method, or if that's not making a lot of sense, you can actually start with the answer choices. So this question, back to number 1, it says, what is x? So it's giving you possible x values, right? So what you're going to do, you're going to take that those possible x values, and you're going to plug them in to where the x's are, and then you're going to solve for y on both of them. If you get the same y for both, that's your solution. So let me show you what I mean. So let's start with 0, okay? So we're going to put that where x is. So in the first equation, it's going to be 0 plus y equals 4, and in the second equation, it's going to be y minus 0 equals 2. So if I was to solve this first equation, 0 plus y, that's really nothing. So this one's saying y equals 4 when x equals 0, right? Second equation, to solve that, y minus 0. Okay, minus 0 is just the same as y. So this one's saying y equals 2. Well, these two y values are not equal. So I would cross out answer choice A and I would keep trying, right? Now we said the answer was 1, right? So let me show you what's going to happen if we replace our x's with 1 so you can see how that works. Okay, so we're going to put 1 plus y equals 4, and then y minus 1 equals 2. Okay, let's solve these. The equation on the left, I'm going to solve for y by subtracting 1 on both sides. So I get y equals 4 minus 1 is 3. Okay. Now I'm going to replace the x on the other equation, or I'm going to solve the other equation for y. I'm going to move that minus 1 to the other side by adding it to both sides. So we get y equals 2 plus 1, which is also 3. These are equal, so that means that was my solution. So that's another way to solve it, which might be easier for a few of you. All right, number 2 is also a system, but if you look at the first equation, there's only one variable, one kind of variable, whereas the second equation has 2 different variables, right? In number 1, both equations had an x and a y. But now, one equation just has an x. So if you ever get that, you're going to go ahead and solve for that x. If I want to solve for that x, I'm going to divide both sides by the 7. So x equals, whoops, I forgot to put my divide. 2 divided by 7, which is 2/7. Do not convert this to a decimal because it will be a repeating decimal and it'll mess you up. So x equals 2/7. So in order to find what y is, I need to replace the x in the other equation with the 2/7. Now I know that looks a little scary. Some of y'all are scared of fractions, but check it out, it's not that bad. So we've got 3y minus 7. Instead of x, we're going to put 2/7 equals 10. Okay, now we're just going to solve. To multiply 7 by 2/7, I put the 7 over 1, and then I multiply my numerators together. So we have 3y minus 7 times 2 is 14. 1 times 7 is 7. And 14 divided by 7, whoops, is just 2, equals 10. Okay. Now our y's are on the left. We're going to move that minus 2 to the right by adding it to both sides. So on the left, we get 3y equals 10 plus 2 is 12. Now we're going to get rid of our 3 by dividing both sides by 3. So y equals 12 divided by 3 is 4. So our answer to number 2 is 4. For number 3, both equations have x and y, so we can either plug in each answer choice for x into both of them and see which one gives you equivalent y's, or we can try to think of a clever way to solve this. I'm going to try to solve it with elimination because I know a lot of students like that. And if you look at the two equations, they don't look to be in the same form. The one on the left has a 2 in the denominator. So remember, the easy way to get rid of that is to multiply both sides by that denominator of 2. These 2's cancel, so what we're going to get is just x plus y on the left equals 4 times 2, which is 8 on the right. Now if I look at both equations, they do look like they're in the same form. They have their x first, then their y equals their constant. Let's go ahead and line them up on top of each other to see if they're ready to add. Okay, so we want to look at our coefficients. On the x's, they both have positive 1s. Those are not opposites. On our y's, I have a positive 1 and a negative 1. Those are opposites, so these are ready to add. When I add them, the positive y and the minus 1y make 0. They go away. So on the left, the 1x plus 1x is 2x equals 8 plus 4 on the right is 12. Now I have this little tiny equation which I can solve. I'm going to divide both sides by that 2. So x equals 12 divided by 2 is 6. And it says then x equals, so I don't have to solve for y. So I can see that my answer is C. If I solved for x right here and then it said y equals, then remember I would plug in that 6 for x into either equation where the x is and solve for y. Okay, let's look at this system. This system, both equations are already in the same form. So I just want to look at their coefficients to see if I have opposites, if I want to solve it by elimination. If I look at my x's, my coefficients are 4 and 3. Those are not opposites. If I look at my y's, my coefficients are 3 and 2. Those are not opposites. So this is where I might have to do something to one or both of my equations. First, I need to decide which variable I want to get rid of. If I'm solving for y, it would make most sense to get rid of my x. So I want you to look at both of the x's. I've got a 4 and a 3. What I basically want to do is kind of like finding common denominator. I'm going to multiply 4 times 3, which is 12. And then I'm going to multiply both equations by whatever number I need to get 12 and negative 12 as my coefficients, right? So the first equation, in order to make my x 12, I need to multiply that 4 by 3. And in the bottom equation, to get that x to be 12, I need to multiply that 3 by 4. So 3 times 4 is 12, and 4 times 3 is 12, but I need one of them to be negative. So I just can make one of them negative. I'm going to make the top one negative. It's no big deal which one you use. Now what we're going to do, we're going to distribute that number to every term in the equations. Okay, so we're going to get some new looking equations. So the first one, negative 3 times 4x is negative 12x. Negative 3 times 3y is negative 9y equals negative 3 times 6 is negative 18. Then for my bottom one, 4 times 3x is 12x. 4 times 2y is 8y equals 4 times 5 is 20. Now if I look, my equations, my x's have opposite coefficients, so I'm ready to add these equations together. My x's eliminate. So we're going to go ahead and add everything else together. Negative 9y plus 8y is negative 1y equals negative 18 plus 20 is positive 2. Now to get the y by itself, I'm going to divide both sides by that negative 1 in front of the y. And y equals 2 divided by negative 1, which is negative 2. So that means, what is y? Y is negative 2, which is b. All right, number 5 is a system of 3 equations. Notice we have 3 variables. However many variables you have, you need to have that many equations or more to solve this system. This one would be kind of tricky to do elimination, so I'm going to suggest plugging in some answer choices. It says x equals, these are our possible answer choices. So let's go ahead and start with the 1. I'm going to put 1 everywhere I see x, and then just kind of look at what we got and see what we've got. So in the first equation, if I put 1 where x is, we're going to get 1 plus y plus z equals 10. In my second equation, if I put 1 where x is, we're going to get 1 minus y minus 2z equals negative 13. And in my last equation, if I put 1 where y is, we're going to get 1 plus z equals 6. Now if I look at that last equation, I've narrowed down my variables to just one variable, the z, right? So this would be very easy to solve for. All I have to do is move that 1 over by subtracting it from both sides. So z equals 6 minus 1 is 5. Now that I know the value of another variable, I'm going to go ahead in my other equations and I'm going to put 5 where z is. And then I can solve both of those for y. If I get the same y value in both of those, then I know a was my answer. So let's see what happens. In the first equation, we've got 1 plus y plus my z I'm replacing with 5 equals 10. Whoops. To solve this, first I'm going to add the 1 and the 5 on the left, which is going to make 6. So I've got 6 plus y equals 10. And then to solve for y, I want to move that 6 over by subtracting it on both sides. Oops, I'm kind of running into the other one. Let me erase this real quick if y'all are okay with that. Okay, so on the left side I have just y, And on the right, 10 minus 6 is 4. So if I get 4 in the other equation for my y, then I know I did this correctly. So in the other equation, we've got 1 minus y minus 2 times, instead of z, we're putting 5, equals negative 13. To kind of solve this, simplify, negative 2 times 5 is negative 10. So I've got I've got 1 minus y minus 10 equals negative 13. I can go ahead and combine the 1 and the negative 10. 1 minus 10 is negative 9 minus y equals negative 13. Then to get the y by itself, I want to move that minus 9 over by adding it to both sides. So on the left, I've got negative y equals negative 13 plus 9 is negative 4. And then the last thing I have to do is get rid of that negative in front of my y. That's a negative 1. So I'm going to divide both sides by a negative 1. And I'm going to have y equals negative 4 divided by negative 1 is positive 4. So since that's what I got over here, then that's our answer. We got kind of lucky. Now, that took a long time. You might have to do this with each answer choice. We kind of got lucky there. And the correct answer is A. Okay, on exercise 4 for number 1, we are given a function. And then we're told, what is f of negative 3? So what it's telling you here, whatever's in the parentheses, that's telling you that's basically telling you what x is up here. So you're going to go to x in your function rule and you're going to replace it with that number. Now because my x value is a negative 3, you want to make sure you always plug in a negative in parentheses. So when I replace it, it's going to be 2 times, instead of x, parentheses negative 3 minus 4. And then all we have to do is simplify this. 2 times negative 3 is negative 6. Negative 6 minus 4 is negative 10. So f of negative 3 equals negative 10, which is answer choice A. That is called evaluating a function. Number 2 says, what is the slope of the line? A line, remember, has a basic form of its equation. That's y equals mx plus b. Remember that slope is our m. That's our m. M is the slope, rise over run. B, on the other hand, this constant at the end, that's your y-intercept. That is where x equals 0. That's where your graph crosses the y-axis. Okay? But in this case, it says, what's our slope? Slope is m. So m is 5. So our answer is B for number 2. Okay, for number 3, you're given 2 points, and it says, what is the slope? Now, you can use this equation if you remember how, sorry, not y equals. If you remember how this works, slope is equal to y2 minus y1 over x2 minus x1. But I taught you guys an easier way to do this in class using a table. So if we make an xy table, and we put these 2 points in our table. So I've got 0, negative 5, and I've got 8, 27. What we're going to do is we're going to look for the change in the y, how the y changes, and the change in the x, how the x changes. So for my change in y, what do I do to negative 5 to get 27? I've got to add 5 to get back to 0 plus another 27, so I've got to add 32. To negative 5 to get 27. This is my change in y. For my change in x, to go from 0 to 8, that's a little easier. I'm just adding 8, so that's my change in x. Slope, or m, is equal to the change in y over the change in x. So all I have to do is replace it with these numbers. So change in y is 32. Change in x is 8. 32 divided by 8 is 4. So the slope is 4. A. Number 3. For number 4, we're also finding the slope. So once again, I can make a little XY chart, XY table, and I can put these 2 points in my table. I've got negative 3, 5, and 8, 5. Now, we want to find the change in Y, and we want to find the change in X. If you look at my Y's, they do not change though. Okay, 5 to 5 means adding 0. Okay. All right, well, let's just keep that in mind. On the x's from -3 to 8, I'm going to go 3 to get from -3 to 0 plus another 8. So that's plus 11 for my change in x. Now remember, slope, or m, is change in y over change in x. If I put these numbers in there, my change in y is 0 over my x, which is change in x, which is 11. 0 divided by anything is going to be 0. So my slope is 0. Now if I think about this, because my 2 points have the same y as of 5, whoops, they're going to be, if I connect them, they're going to be horizontal. Well, that kind of line has a slope of 0. Now on the other hand, if, let's just say if, we know the answer to this one is 0, right, number 4. But let's say instead of 0 over 11, we had 11 over 0. Anything over 0 is undefined. In that case, you would have no slope. And your equation, or sorry, your graph would be vertical. Vertical is no slope. If you can't walk up this line because you're going to fall, then that means there's no slope. Okay, for number 5, if you look at your equations, they're in standard form, and there's some fractions, and you're trying to figure out which of these equations here makes this graph. Okay, so we could do this a lot of different ways. I think the easiest way for you guys is to basically make sure that these xy pairs both make the equation true. Okay, so basically, let's say I start with A. I've got x plus 2y equals 6, right? And let's say I start with the point 0, 3. So I have an x and a y value. What I want to do is I want to put the 0 where x is, and I want to put the 3 where y is, and see if it makes the equation true. So it's going to look like this. For x, I'm going to put 0 plus 2 times, for y, I'm going to put 3, so times 3 equals 6. And then I'm going to simplify. 2 times 3 is 6, plus 0 is 6, 6 equals 6. Yes, it makes that true. Then I'm going to do the same thing, but I'm going to try the other point, which is 6, 0. Let's switch out these numbers for 6 and 0. I'm going to make sure that this point also works. So I know the first point works. So when I replace the second point in, for my x, I'm going to have 6 plus 2 times for my y, I'm going to have 0 equals 6. Simplify. 2 times 0 is 0, so this is gone. So 6 equals 6. That is also true. So this point also makes that equation true, so that means A is my answer. Now if A didn't work, I would go to the next one. I have to make sure that both points make the equation true. Because let's say I just know that this point works in the second equation. Well, that doesn't mean the line couldn't look like this, right? Yeah, it could have that point, but we need to make sure it also has this point. So you need to try both points in each one. That's probably the quickest way for these. So the answer to this one was A. Okay, exercise 5, number 1. A group of cyclists is planning a 50-mile ride. I'm reading this for y'all because it's a word problem. We need to make sure we get all the important stuff. The cyclists will stop every 10 miles to rehydrate. So if we think about that, if they're going 50 miles, they're going to stop every 10 miles. They're going to stop 5 times, so 5 stops to rehydrate. If each cyclist will drink X pints of water at each rest stop, at each of the 5, how many pints of water will each cyclist drink over the course of the ride? They have 5 stops. At each stop, they're drinking X pints. So the expression that represents the number of pints they'll drink over the whole race or ride is 5x. The answer to this one is C. All right, number 2. In a run-walk race, Weber runs X miles in H hours. So that would be his speed, miles per hour. Then he walks, put equal signs, doesn't look like a negative. Then he walks the remainder of the race route, which is Y miles in the same number of hours. So he walks Y miles per hour. That's his rate, miles per hour. Which of the following represents Weber's average speed in miles per hour? So average means you add two things and you divide by how many you have. Well, we have two things, right? So our average is going to equal one speed plus the other speed divided by the total number of speeds we have, which is 2. So we have to simplify that. Okay, so we need to remember some of our rules. Let's look at our numerator. We have to have common denominators in order to add fractions, which we do. So in our numerator, x over h plus y over h is going to equal something over h, right? So all we have to do is add our numerators. In our numerator, x plus y is x plus y. Okay. Now we have this fraction divided by this number. I want you to remember that dividing by something is the same as multiplying by its reciprocal. Meaning if you flip it, you can multiply by its reciprocal. If 2 is the same as 2 over 1 and I flip it and make 1 over 2, then dividing by 2 over 1 is the same as multiplying by 1 over 2. So to multiply, we just multiply our numerators and our denominator. X plus y times 1 is just x plus y. And h times 2 is 2h. So the answer here is x plus y over 2h. So these are going to be just kind of manipulating variables. It's going to be very abstract. So the way you want to start is really have a clear idea of the information that they're giving you. For number 3, it says d is distance, r is rate, t is time. So distance equals rate times time. How long, so that's time, will it take Darren to drive 180 miles? So that's our distance. So for distance, we're going to put 180 equals at an average rate of 45 miles per hour. So for r, we're going to put 45 miles and then times t. So all we have to do, since we're finding t, is solve for t. So to get rid of the 45, we're going to divide both sides by 45. Okay, 180 divided by 45 is 4. So t equals 4 hours. So the answer to number 3 is C. Okay, this problem is talking about profit. Profit is what you get after you've subtracted expenses from what you've earned. So profit is what you earn minus expenses, what you spent. Okay, so we want to know how much profit, the minimum selling price per brownie to make a daily profit of at least $420. So we want the profit to be $420. Now, how much does he earn? Well, he earns whatever he sells the brownies for times the number of brownies he's sold. We need to figure out the price for the brownies. So we don't know what he's selling the brownies for. Well, let's call it X, right? So let's say, So let's say, and it says that all the brownies are sold each day and he makes 400 brownies a day. So he's selling 400 brownies at some price we don't know. And to make those 400 brownies, he had a cost of 25 cents per brownie. Well, if he made 400 brownies and he had to spend 25 cents per brownie, that would be 400 times 25 cents. So all we have to do is solve this equation, okay, for X. So the first thing we want to do is go ahead and multiply the negative 400 times the 0.25. So 420 equals 400x minus 400 times 0.25 is 100. Then all our x's are on the right, so to get all of our constants on the left, we've got to move over that minus 400. We're going to do that by adding 100 to both sides. And that's going to give us 520 equals 400x. And then the last thing we're going to do is get that 400 by itself. And to do that, we're going to, to get rid of the 400 to get the x by itself, to do that, we're going to divide both sides by 400. So x equals 1.3 or 1.30. Now, remember, you will be able to do that kind of dividing. And that is the price per brownie, so that's $1.30, and that is answer choice A. Okay, the last problem, this is a rate problem. All of these are about rate in exercise 5. Lots of times, rates you can solve with proportions if you just look for similar units. So we have a pump that removes water from a tank at a constant rate of 240 gallons per 1 minute. So we can say 240 gallons per 1 minute. Okay? So let's set up the second side of our equation with gallons also per minute. It says operating at this same rate, how much water, which would be how many gallons, will the pump remove in 5 minutes? So this is what our proportion looks like. We're going to go ahead and solve by cross multiplying. X times 1 is x. 240 times 5, I think it's 1200. These are our cross products. They're always equal. Check it out. It's already solved. X equals the number of gallons, so that's 1200 gallons, so that's answer D. Okay, if there was any question in here that you're still struggling with, come find me. I hope this helped, and have a great day.